Number 25. Does f of g equal g of f? Also, we sometimes will say fog or goff. Do these equal to each other? Are these commutative? Now, let's talk about what this means. F of g is the same thing as f parentheses g of x, like this. And this is the same thing as g parentheses f of x this way. So let's find these. First, I'm going to put g inside of f. Now, I think this is easier if I write this vertically. And I'm going to write f's equation is 4x plus 3. And I'll put g below it. What I'm going to do is I'm going to insert g into f first. So I'm going to take this part of the equation and insert it there. When I do so, I would get 4 times, instead of the x, we'll have x squared minus 7, and then the plus 3, and I would solve this out. And so 4 would distribute here, so you'd have 4x squared minus 28, and then I have the plus 3 over here remaining. And when I simplify, I find out that f of g will equal 4x squared minus 25. So there's one answer. Now I want to see if these are commutative. So I'm now going to do the same thing, but this time I'm going to put f inside of g. So I'm going to say g equals, it was x squared minus 7, and f equals 4x plus 3. So this time, to put f inside of g, I'm going to take this equation here and replace it with x. So that means I would have not x squared, I'm sorry, 4x plus 3 squared minus 7. Now we got to discover if these are equal to each other. So I would write this parenthesis twice, 4x plus 3 times 4x plus 3, and now I'll subtract 7. I'll FOIL this through here. 4x times 4x is 16x squared. This is going to be 12x. I'll have another 12x. And finally, I'll have a plus 9 minus 7. When I simplify all that, I get 16x squared plus 24x minus 2. Because these combine together, and these also combine together. And so this would be g of f. Do these equal each other? They do not. They're different. So since they are different, these are not commutative. These are not commutative since f of g does not equal g of